Tomorrow we've got a quiz on all these derivative relationships. The quiz is going to be multiple choice, free response. Tonight's homework is going to be excellent preparation for the multiple choice. For the free response, there is a sample question on page 25. What you need to do, read through this carefully, make sure you know what graph you're talking about. The goal is for you to be able to answer parts A, B, C, and D in 6 minutes or less. Do not talk to anybody else. If you can do this, this tells me you're in a really good place for tomorrow. When the timer goes off in 6 minutes, we'll go over the solutions. Use this time wisely, everyone. Use your notes if you need to. Is this the homework? Okay. So both assignments are both of you. Nice. Okay. Homework file? Okay. So both assignments from all 5?
Yes.
Okay, see you at lunch. Okay, homework file? Okay, both assignments from all 4? Oh, what? Please plan. See you at lunch. Homework file? Both assignments from all 3? Naum is dabbling with the dark side. Don't do it. It took Darth Vader a long time to leave the dark side. Hi there. For f prime, it's irrelevant because f prime is changing from degrees into degrees. But remember, what you see is f prime, but I'm asking about f. So be careful. You cheat. A. What? Now, I don't write that fast. And let's see how we do. That we are not working at a good pace here. Part A. Okay, so part A, determine the x-coordinate for all horizontal tangent lines. Horizontal tangent line, if the graph of f has a horizontal tangent line, how do we use f prime? What has to be true about f prime? F has a horizontal tangent line, that means that f prime is equal to 0. So the first thing I'm going to write, f has a horizontal tangent line when f prime is equal to 0. First point.
Yep.
It doesn't have to be the first thing that you write, but you better make this connection somewhere. And as soon as you make that connection, you've locked in a point that I cannot take away from you. Now tell me where that happens. Where's f prime equal to 0? Negative 5, negative 1, positive 5. List those 3 points and no others, you get the next point. Now we just need to go through and classify. Is it a relative max? Is it a relative min? Is it neither? At x equals negative 5, I see f prime is changing. F prime was above the x-axis. It is now below the x-axis. So what happens?
Max.
This is the relative max. F prime changes from positive to negative at negative 5. F has a relative max. Okay, what about negative 1? F prime changes from negative to positive at x equals negative 1, so f has a relative minimum. Done. Another point. X equals 5, what's happening at x equals 5? There is no change in sign. So, max? No? Min? You have one option left. Don't say saddle. What did they give you as your options? They said max, min, or neither. So it is neither. This is one of those places where, because I'm such a good teacher and I teach you guys all about saddle point, everybody wants to write saddle point. And it might be okay, but if they say classify as max, min, or neither, you have to go with neither. Are you okay? Good. All right, B, for the interval -7 to 7, find all the places where f is concave up. If f is concave up, f prime is increasing. First point. Where is f prime increasing? I go to my graph. From -3 to 2 and from 5 to 7. -3 to 2, 5 to 7, another point. Looks like Kevin's rocking in some points here. C, identify all the intervals where f is concave down and decreasing. F is two things, f prime is two things. If f is concave down, f prime is decreasing. If f is decreasing, f prime is negative. Where is f prime? Both. Decreasing and negative, go back to the graph. Where's f prime? Decreasing and negative. From -5 to -3, and that's the only place where it happens is -5 to -3. Okay, lastly, find all the coordinates for points of inflection. If f has a point of inflection, I saw a couple of folks write, that means that f changes concavity. That's true, but you don't see f, what you see is f prime. So I need true statements about f prime. What's true? F has a point of inflection. Kevin knows it. I'm worried that more people don't know it. If you're not sure, go back in your notes. Find that table where we summarized everything. Take a minute. Get this part finished. I think most of you guys didn't get here. F has a point of inflection. What's true about f prime? F prime has to change from increasing to decreasing, or decreasing to increasing. So look at the graph. Where does f prime change increasing to decreasing?
From -5 to -1.
Not from. There's a place. There's a place where this graph changes from increasing to decreasing. That's over here at x equals 2. Right? F prime is the graph you're seeing. I was increasing, now I'm decreasing. That's a point of inflection. The other place is where f prime changes from decreasing to increasing. That happens at x equals -3. So what I want you to have in your notes, oh, and at 5, my bad. And at 5. Okay? So f has a POI, point of inflection, when f prime makes a change from increasing to decreasing. That happens at x equals 2. First point. Pedro, are you okay? You get all this written down? Or when f prime changes from decreasing to increasing, that happens at x equals -3 and x equals 5. Done. A through D should be the easy ones. These should be the ones that everyone's going to do really well on tomorrow. I'm just testing, do you know your derivative relationships? Do you know what graph you're looking at? Do you know how to write things effectively? Jose, one of the things tomorrow, if you identify the interval, great, that's a point. But if you don't give me this part up here, this is the justification where you explain the f prime connection, I cannot give you the second point. Questions on A through D before we hit the hard stuff? Delia.
So for A, you know how it's talking about the horizontal tangent lines?
Yeah.
I thought that when you look at the horizontal tangent lines, you look at this.
Okay, you're right, but here's the thing. Which graph am I asking you about in part A?
F of X.
F. What graph is this?
F prime.
F prime. What you drew on your paper, you said like over here, and over here. Those are horizontal tangent lines, but for F prime. I'm asking you in part A about where are the horizontal tangent lines for F, the graph you don't see. And the connection is that F has a horizontal tangent line when F prime is a root. Okay? All right, so let's keep going. Juan, you're going to make it. Juan, you're going to make it. I know you're going to make it. No one has ever died on me in class. I've been tempted to choke some people, but since I'm on film, it's really hard to do that convincingly. Hey, Nahum, if I'm standing over here, am I seen on film?
No.
Oh. That's good. Just checking. He might just disappear. Okay. All right. Here comes the hard stuff. This is going to separate out the people that are going to do really well from the people that are just barely going to pass. Same graph. Part E. Assuming that f of -3 is equal to 4, find the equation of the tangent line. Oh my God, we've done this so much. Have a quick conversation with somebody near you. How are you going to find the equation of the tangent line at x equals -3? Don't tell me. Tell the friends around you. The equation of the tangent line, there are two things we need. We need a point and we need the slope. You have to have both. Okay? So Jose is saying that we know that f of -3 is 4. So that's the point. The point is -3, 4. Where does the slope come from? I heard some people earlier say rise over run, but that's not calculus thoughts. Where does the slope come from?
F of x minus f of a.
Oh, you guys are overthinking this, which is a rare moment here. I want the slope of f at x equals -3. You have another way to say that. You want the slope of the tangent line at x equals -3. Another way to say that is tan. Another way to say that is begins with a D. We've been doing this for weeks now. Thank you for not saying derivative. The slope is the derivative. So what's f prime of -3? What's f prime of -3? You have a graph in front of you for some reason. What's f prime of -3? It's -2 beta. How on earth did you come up with -2? It says on the graph. This is the graph of f prime. F prime of -3 has to be -2. So now just pull it all together. I always write the equation of my tangent line as L of x. It's your slope, x minus -3 plus 4, or even better, -2 times x plus 3 plus 4. Done. That's the equation of a tangent line. In terms of how I would award points, probably 1 point for coming up with the slope, 1 point for coming up with the equation. Done. All right, part F. This is the one we're all going to get wrong. No, trust me. As much as I love you all, you guys are more likely to get this one wrong than right. Part F, using your equation of the tangent line in part E, estimate the value of f of -2.8, then decide if your estimate is an overestimate or an underestimate. So using the equation of the tangent line, get me your estimate for f of -2.8. We've worked on this skill several times now. F of -2.8. I need to approximate it. How am I approximating it? With the tangent line that I came up with in part E. And so even if for some reason, Jackie, you were to make a mistake on this tomorrow, as long as what you do next is, oh, -2 times -2.8 plus 3 plus 4, done. Full points. Do you need to simplify?
No.
No. If it was the multiple choice part of the test, Name was like, what? What do you mean? If this was the multiple choice part of the test, you're not going to see this as an answer. You're going to have to know that -2.8 plus 3 is what? 0.2. That -2 times 0.2 is -0.4. That -0.4 plus 4 is
3.6.
3.6. Stop saying 3.8. Okay, 3.6 is the right answer for multiple choice, but this is where you stop for free response. Don't simplify it, because Ashley, right now you get the full point, but if you go down the road and you make a mistake and you say 3.8, I have to take that point back. Okay? So don't do it. Even though I like you better than anybody else. It's not true. Okay. Last one. There's a lot of people I like in here. Here's the part though. Is that an overestimate or an underestimate? And how would you ever decide?
Oh, if it's concave.
You want to think about concavity here. The way you decide over and underestimates has to do with concavity. What kind of concavity are we looking at? Concave up or concave down? Concave up? If we have concave up, what kind of an estimate? Underestimate. Concave up, draw those tangent lines, they're always below, so you get an underestimate. Now here's the problem. With all of these estimates, they always have to start this way. From a place to a place. The place that you want is your point of tangency. The place that you're going to is the place that you're estimating. So in this case, where's my point of tangency? Where's the point that we built the tangent line above? From x equals -3 to the point that I'm estimating, -2.8. What do we know about the concavity? I'm hearing concave up, I'm hearing concave down. And here's the problem. I think everybody's looking at the wrong graph. If you're looking at this graph over here to use your S to come up with your idea, what's wrong with that?
That is a derivative.
This is the wrong graph. This is F prime. If I look from -3 to -2.8, I think some of you are saying, oh, well, this graph, right, is concave up. So my tangent lines are below. But this isn't F, it's F prime. There is something about F prime, though, that you can use to get to concavity. What's F prime doing?
You're crazy.
I mean, I'm crazy? Oh, I am crazy. But from -3 to -2.8, Jose says F prime is increasing. True or false? Is F prime increasing? True. Tell me about F. What's F doing?
It's positive.
Not positive. We've got F, F prime, F double prime. F prime is increasing. What I think you guys are thinking about is F double prime. F double prime is positive. That's true. But what's F? Concave up. F is concave up. F is concave up. It's that. Remember this guy? Concave up means the second derivative is positive. So F is concave up. So what? The tangent lines. Where are those tangent lines? Tangent lines are below the graph. So what kind of estimates? Tangent lines are below the graph. Pedro, I think you stopped writing notes. Are you still breathing over there? Good, just checking. We're below the graph, so we've got an underestimate. If I were you, if I was any of the teenagers at home, I would put a great big star next to this. I ask these estimate questions, oh my God, every single quiz, every single test, every single unit test, and every semester exam that I've written for the last 5 years. Because it's so important and there's so much to get wrong here. All right, so now, you guys asked me about this the other day and I did not deliver on it. We're finally going to do a little bit of curve sketching here. So this is the last piece before we move on for a bigger push. You've got in front of you the graph of F prime, which is the blue. In red, I want to graph F double prime. So, take a minute, put the books that are around you, start making your list of thoughts. What are the things that you know for sure about f double prime? What do you see about f prime? What does it mean about f double prime? There are other concepts that. You got a double period. Right there on one of them. You're still there. Got the graph of f prime. What has to be true? Come on, you need to wake up or stand up. Things that we know about f double prime. I'll take anything from anybody. Jackie, one thing you know about f double prime and why you know it.
That it's going to have 3 zeros.
Okay, Jackie says f double prime is going to have 3 zeros. Why?
Because you have a horizontal tangent line
For which graph?
for f prime.
So f prime, I hope everybody's okay, we've got a horizontal tangent line here.
Yes.
You've got a horizontal tangent line here. And you've got a horizontal tangent line over here. I'm going to try to stick with blue and red. Blue is f prime, red is f double prime. So Jackie, what do you know?
So there's going to be a 0 at negative 3,
A 0 at negative 3,
a 0 at 2,
a
and
0 at
5.
2, and a 0 at 5. Nice job. What else? Kevin?
X equals -3, f double prime is going to go from negative to positive.
I agree with you. Tell me why.
Because it has a relative.
At negative 3, f prime has a relative min, which means that my second derivative has to go from negative to positive. So my graph is going to have to do something like that. Completely agree. What else? What else? We got a whole lot more facts. What else? What else? What else? Kaylin? At x equals 2, what's happening? F double prime goes from positive to negative because f prime has the relative max. Love it. Okay, what else? What else we got? Jose?
At x equals 5, it has a relative minimum.
At x equals 5, not it has a relative min. What has a relative min?
Prime has a relative minimum.
F prime has a relative minimum. F double prime?
It goes from negative to positive.
From negative to positive. Now that's good. That's a good start. Ashley, what else?
Here's a vertical tangent line at x equals 3.
F prime has a vertical tangent line. Vertical tangent line. Love it, Ashley. So if f prime has the vertical tangent line, what's true about the derivative?
Does not exist.
What's true? F prime has a vertical tangent line. Go back to that table if you need to. The original function has a vertical tangent line. Delia, what's true?
F double prime has a vertical asymptote.
F double prime has a vertical asymptote. Nice. That's true. Okay. Oh, sorry. And you still can't catch. Okay, that's also true. Anybody else see anything else that's going to help you with this graph? I told you about points of inflection. There's a point of inflection
2.
here, here, and I think over here. At points of inflection, your concavity changes. You were, what kind of concavity here?
Positive. Oh, that's a concave down.
That's concave down. Now there's something else you can say.
Decreasing.
Concave down and decreasing, which means when I go and I sketch the derivative, if this guy is concave down, I need to do something that is decreasing. But if this guy is decreasing, then I also need it to be negative. I need decreasing and negative, so give me decreasing and negative until I get to x equals -5. Where you have the point of inflection, that's where you stop being decreasing and negative. Well, how about this next interval? -5 to -3, two things that are true. We're concave up and decreasing or increasing?
Decreasing.
We're decreasing. So if this guy is concave up and decreasing, on this next interval I need to be increasing but negative. Increasing but negative all the way until I get to x equals -3. Finish it off. I need you to step outside. Next interval, concave up and increasing. If all goes well, you're going to draw increasing and positive. So increasing and positive until I get to -1. This next interval, what is that? Looks like, wait, what just happened there? Yeah, all the way to 0. My bad. My bad. All the way to 0. Thanks, Jose. This next interval that I'm going to look at, I'm going to look from 0 to 2. I'm concave down. And I'm increasing, so my derivative graph has to be, if the derivative is concave down, then the next guy is decreasing, but positive. Decreasing but positive until I get to x equals 2. Decreasing and positive. Now over here, I'm concave down and decreasing. So concave down and decreasing, I need to be decreasing and negative, but I also have this vertical asymptote to play with. What you have to do is decrease and negative, but get close to that vertical asymptote. You're just going to have to go all the way down. After that, this next interval, I can see that I'm concave up and decreasing. Concave up and increasing means that the next derivative is increasing and what, negative? Increasing and negative, and oh, there's a vertical asymptote. Increasing and negative. This last piece, I'm concave up and I'm increasing. I need to be increasing and positive. That would be the sketch.
Yeah.
And it's in the saddle point. Yeah, I might get on board with saying that's a saddle point. Sketching the graphs, I know, is the hard part. But you guys did a good job in the beginning, so I think we're good. So I've got one last push. Let me go get my friend back. What I want. All right, time for the push. The training wheels are coming off the bicycle. Carlos, you with me back there? Evelyn, are you with me back there? And Delia is with me. 2 out of 3 is not bad. All right, so training wheels coming off the bicycle. For the first time ever, you get no graph. And that's fine because you are some smart human beings. For the function f of x equals x to the 5th minus 5x to the 4th plus 2, answer the questions that follow. As always, be sure to justify your answer. I need to know where f is increasing. Previously, you would have said things like, oh, well, I know if f is increasing. What do we know for sure?
It's positive.
Not it's positive.
That function.
Not the function f prime. And what you would have done previously, you would have said, oh, well, let me go look at the graph. And when the graph is above the x-axis, this is when f is increasing, okay? This is how we would play the game. The problem, though, is you don't know what the graph of the derivative looks like. It has been withheld from you. You need a different strategy. I would hope that everybody can tell me what f prime is. That's like a 3-second question at this point.
Oh, it's gonna be 5. Okay, so 5
And 3,
minus
2, and 1. What do we got? 5x to the power 4.
minus
Minus
20x
20x to the power
cubed.
3.
Okay, and what about that 2?
It's constant.
It's a constant. Derivative of a constant is going to be 0.
Yeah.
Okay, so hold on. I'm asking where f is increasing. We found the derivative, and now we're going to ask the question, where's the derivative greater than 0? This should be bringing you back to pre-calculus thoughts. Way back in the day when you had Mr. Link, there was a way that you would solve inequalities. Before you met me, there was Mr. Link. There was this whole section on solving inequalities, and I heard Jose say something about factoring, but it actually starts a little bit before that. Rather than dealing with the inequality, you change the problem and you say, where is 5x to the 4th minus 20x cubed equal to 0? This isn't a calculus question anymore, it's a pre-calculus question. How am I going to figure out where 5x to the 4th minus 20x cubed is equal to 0? Maybe you want to factor. Is there anything I can factor here?
5.
5, anything else?
X
5x cubed, and what it leaves me with,
X minus.
x should be x minus 4. 5x cubed times x minus 4 is equal to 0. What are the solutions here?
We have a 0.
Okay, x equals 0 is a solution.
X plus.
And x equal, right, you'd say x minus 4 equals 0, x equals 4 is a solution. Are there any other solutions? Not that you know of currently. That's a safe thing. Could there be any others?
Yes.
Yes.
Okay, how many should there be? At
3.
most. 3?
4.
4.
There's 4, right? Degree 4 means at most 4 roots. What's happening though is this x cubed, you guys would have called it a root of multiplicity 3. Or you would have called it roots, but this is a like triple root. Last year in pre-calc we had questions about, does the graph pass through at x equals 0 or does it bounce at x equals 0? These are some conversations you would have had. What we're going to do is we're going to do something called the number line test. Here's what I know. We're going to create a number line for f prime. Here's x equals 0. Here's x equals 4. All the other numbers in the world are also on this number line. But what makes 0 and 4 special is that f prime is equal to 0 at x equals 0, and f prime is equal to 0 at x equals 4. These are the only roots. There are no others. And so what you do is it's called picking a test value. You're going to pick a test value to the left of 0, and this is exactly what you did in pre-calc last year. So give me a good number to the left of 0. Negative 1. Give me a good value between 0 and 4. 2. Give me a good value after 4. 5. And what we're going to do is we're going to plug them all into f prime to see if we get a positive answer or a negative answer. I know I'm going fast, but you guys did this last year. Plug negative 1 into f prime. 5 times negative 1 cubed times negative 1 minus 4. All I want to know is that a positive answer or a negative answer? Yes, those are the choices. It is a positive answer or it's a negative answer.
Negative.
Kaylin, convince me that this is positive.
Because you multiply, when you cube root the negative 1, it stays negative 1, which makes it negative 5. And when you subtract negative 1 and 4, it's still negative. So
5 is positive. Negative 1 cubed is
Negative.
negative. Negative 1 minus 4? Negative. 5 times negative is positive. Now, here's the thing. That means that if x is equal to -1, my first derivative is positive. But because the only roots are at 0 and 4, not only does -1 make the first derivative positive, all the numbers to the left of 0 make the first derivative positive. Now, how about between 0 and 4? 5 times 2 cubed times 2 minus 4. 5 times 2 cubed times 2 minus 4 is negative. This whole interval, f prime, is negative. At x equals 5? 5 cubed, 5 minus 4. And for everybody who's freaking out, they're like, I don't know what 5 cubed is. I don't care.
125.
What I know is it's 125. Way to show off. That was your moment! 5 cubed is 125, but all I care about is one thing. Positive. 5 cubed is positive, 5 is positive, 5 minus 4 is positive, so the whole thing? Positive. So where is f increasing?
Left of 0 from negative.
F is increasing means f prime is positive. Where is f prime? Here's f prime. Where is it positive? Negative infinity to 0. Hi there, too early. Bye-bye. And then, no, bye-bye, you're too early.
4.
And then from 4 to infinity. The number line test is some old school stuff. We're just using it in a new way. All right, part B, we get just enough time. Determine the coordinates of any relative extrema, that is a max or a min. Classify each as a max or a min. Well, what has to be true if f has a relative max? Not it goes. The derivative changes from positive to negative. Anybody know where the derivative changes from positive to negative? At x equals 0, so you have to have a relative max. Anybody know where the relative min is? To be a relative min, f prime changes from negative to positive. So you're going to have a relative min. Okay? Tonight's homework is just a bunch of multiple choice questions that are going to get you ready for the quiz tomorrow. If I did not get both assignments, you need to be in this room by 12:40. Sorry.